All right, guys, this is going to be the next lesson for 3D figures. We're going to start finding the surface area and the volume of prisms and cylinders only. So prisms and cylinders, those two are closely related, so it'll be hopefully an easy lesson. So what is surface area? You did a little bit of this in middle school. This is when you take the sum of the areas of all the faces or surfaces, those mean the same thing, that enclose the solid. And so think of it as painting the figure. Lateral area. Sometimes you'll find only the lateral area. That's the sum of the areas of all the lateral faces, which we talked a little bit on the last lesson what lateral faces are. Those are all the faces other than the two bases. And then volume. This is the measure of the amount of space in the solid. So two units that we're going to work with, the units are units squared for your surface area and your lateral area, and this one's cubic units, okay? So square units for area, cubic units for volume. So here's the two figures that, like I said, we were going to work on. This is the prism right here, and this is our cylinder right here. And so basically, I just want to go ahead and give you the formulas for each one and write them down because you'll need these for your assignment. For a prism, the volume is capital B times H. And for surface area, it's capital P times H plus 2 capital B. And then the lateral area is just capital P times H. So what does each thing stand for? So capital B stands for area of the base. So capital B means area of base. So you always want to identify what the base is. So in this case right here, a lot of people tend to think that this is the base down at the bottom, okay? In the dictionary, the base is usually at the bottom of the figure, okay? Because base is at the bottom for the solid purposes, but the base in a prism, we had talked about in the last one, is that there's two congruent parallel bases. So there's one, and then there's the identical one in the back. Okay, and remember all the lateral faces are rectangles or parallelograms. Okay, so those two, sometimes those are good to highlight, okay, if you have a highlighter or colored pen. So capital B stands for area of the base. Capital P stands for perimeter of base. Okay, so whatever the base is, you just take the perimeter. And that's pretty much it. The only other part that I want to talk about is this word H, or the letter H right here. That is the height of the prism, and the height of the prism goes from base to base, okay? And it's always perpendicular to the base. So I want you to write off to the side, capital B is perpendicular to H, okay? Maybe off to the side also write H goes base to base. Okay, so everybody thinks the height has to go up and down like that because that's how we take the height of ourselves. We stand straight up and down, but that is not the case. So I'm going to remove that. Okay, so the height goes base to base. Okay, so that's each one. And we'll do some examples here in a minute. Okay, so capital B stands for area of the base. Capital P stands for perimeter of the base. The height is always perpendicular to the base. So this is actually H right here. So let's label that. Okay, and then the red we can say is capital B. So H goes from base to base. All right, let's look at the cylinder. It's very similar to that. The volume formula is the same as the prism, capital B times H. B still stands for area of the base. And in this case, our bases are always going to be circles. Okay, so those are always going to be circles. So capital B is always going to be, in this case, pi r squared, because that's area of a circle. And then our surface area is 2 pi RH plus 2 pi r squared. And then the lateral area is 2 pi RH. Okay, so surface area formula, lateral area formula is given. All of these formulas are always given. Okay, and then the only other thing that I want you to write down is you should know that this is going to be your radius that you should know from circles. And then the height is the same situation over here. It goes from base to base. So that is H, so label that H. And H is also always perpendicular to the circle, capital B. Okay, let's try 2 examples. Okay, these examples are really 4 because we're going to find the surface area and the volume for each one. So let's start off with this one over here. This is a prism. And we're going to find the surface area and the volume. So let's start off with volume. Okay, so volume is capital B times H. Now, capital B stands for area of this base. Now, it doesn't say that it's a regular base, but we're going to have to go ahead and say that it is because there's no other way to find the area of a pentagon. And so you notice I drew in an apothem because I need the apothem to figure that out. So the formula for that is 1/2 apothem times perimeter, and then times H in our formula. Okay, so this is our area formula for capital B. So how do I figure out the apothem? Well, remember we have to draw in our right triangle and figure that out. So this little piece down here, I'm going to just redraw this. This is 6. This is a right triangle, and we have to figure out one of the angle formulas, or the angle measures. I'm going to use my calculator. To figure out the total number of degrees in a pentagon, I take 3 times 180. 3 is 2 less than however many sides there are. So there's 540 degrees. Divided by 5, each angle is a 108 degrees. So each angle right here, those are all 108 degrees. So then I'm going to divide it by 2, because then that gives me this little angle right here. So this little angle right here is 54 degrees. Sorry, my pen is skipping. Okay, so 54 degrees. So I'm going to use trig to figure out the apothem, opposite over adjacent. So it's tangent. So tangent of 54 degrees equals opposite, which I'm going to call A, because that's the apothem I'm looking for, over 6. So when 6 is on the bottom and the variable's on top, I'm going to multiply 6 times tangent of 54. So the apothem for this figure is 8.26. We'll just round to 2 decimal places. 8.26. So now I can plug everything into the formula. 1/2 times 8.26 times the perimeter. What's 5 times 12? Perimeter of the base, that is. So that's 60 times the height. So remember, the height goes from base to base. So that's 21. Okay, I'm just going to enter all of that into my calculator. Actually, I still have the long rational number for the apothem. So I'm going to leave that long number in my calculator. I'm going to times it by 60. Times 21. And then half of that divided by 2. So we've got the volume to be 5,000 202.72 square cubic feet. Sorry, cubic feet. So there's one of my solutions. So I'm going to hide box that. Okay, so there's the volume. Let's go to surface area now. So surface area. I'm going to use red now. So the surface area formula is, let's go back and look at that. Capital P times H plus 2 capital B. Capital P times H plus 2 capital B. Okay, so capital P plus 2 capital B. Okay, so capital P we know. Okay, we did that earlier. That's 60. So I'm going to put 60 times 21 plus 2 times capital B. So capital B, if you remember, is this formula right here, which was 1/2 times 8.26 times 60. Okay, so I'm multiplying 2 times all of that. Now, just to be sure, because I've seen some of my kids do this in the past, you are not going to distribute that 1/2 because everything's being multiplied here. So maybe perhaps me putting those parentheses made it more confusing, but you're not doing the distributive. You only distribute when you see a plus sign or a minus sign inside the parentheses, and that's not the case. Okay, so I'm going to get rid of those little markings. Okay, and so let's do that. 60 times 21 is 1260 plus 2 times 1/2 is just 1. So really, I just need to multiply those two. So I want to be a little bit more accurate. So I'm going to go back and do my trig function, my tangent function, to get the long number of 8.26. Okay, just because I like to be more accurate. So it's 6 times tangent of 54. So I have that long number in my calculator. Now I'm just going to times it by 60, which is roughly 495.497. So I have that long number in my calculator. And then I'm going to add 1260, and that's going to equal, so when I add that, I get 1755.497. And this is square feet. And that's my final answer. Okay, so I just found the surface area and the volume of this pentagonal prism or pentagonal prism. So let's go to the next one. The next one is with algebra. So we want to review algebra because you're about to go into algebra 2 soon. So we are finding the volume and the surface area. So let's do volume first again. So that's capital B times H. Capital B, remember I told you earlier, was pi r squared times H. So I'm going to do pi. R is in parentheses because I have a plus sign, 2x plus 3 squared times H is in parentheses 3x squared plus 5. Okay, so doing this squared right here, 2x plus 3 squared, is like doing the FOIL method. So I'm going to come up to the top over here, and I'm going to FOIL out 2x plus 3 times 2x plus 3. If you like the box method, you can do the box method as well. Okay, so this first terms, 2x times 2x is 4x squared. Inside terms, 3 times 2x, and then outside terms, 3 times 2x. So 6x plus 6x is 12x. And then last terms, 3 times 3 is 9. Okay, so that right there is 2x plus 3 squared. So I'm going to go ahead and write out my new one. So I have pi times, oops, not 4. Four x squared plus 12x plus 9. Now, don't forget, you still have to times it by the height, so I have to do 3x squared plus 5. Okay, so now I have to multiply all of this times all of that. So I'm going to tell you probably the easiest way to do that, so just to make sure you include everything, is to do a box method. Okay, if not, you distribute the 3x squared to everything and then the 5 to everything. But you'll see it's a little bit better visual if you do the box method. So watch me do the box method. So I have two terms over here, 3x squared plus 5, and then I have three terms here. One, let me do that one again. 1, 2, 3. Okay, so 4x squared is here, 12x is here, and 9 is there. So now if you multiply each one, and then whatever ends up being in that box is going to be almost your final answer. We just have to make sure we include the pi. So get a different color. Let's use red. So 3x squared times 4x squared is 12x to the 4th. 3x squared times 12x is 36x to the 3rd. And 9 times 3x is 27x squared. Okay, let's do the last one. 5 times 4x squared is 20x squared, 60x, and 45. So do we see any like terms? I see one set of like terms that we'll need to combine. So I have this one and this one. Those are like terms. Everything else we don't want to combine. So we have, let's scoot down a little bit. We always want to write the highest one first. 12x to the 4th plus 36. You know what? I'm going to need more room. So I'm going to start over. I don't like to roll it off at the end. Okay, so this is 12x to the 4th plus 36x cubed. 27 plus 20 is 47, so plus 47x squared plus 60x plus 49. Now don't forget, we still have all of that times pi, because pi was out here in the front. So you have to include the pi. That's a 12. Okay, so your final answer for the volume, only the volume, is 12x to the 4th plus 36x cubed plus 47x squared plus 60x plus 49, and then don't forget your pi. And this is in units cubed, okay? So now let's try the surface area. Okay, so I'm gonna have to come way down here to show my surface area. So I'm gonna redraw, or actually, let me just drag this down here. Just so we can see it up close. Okay, so now I'm going to do the surface area. And let me go back and review my surface area formula. So my surface area formula is 2 pi RH plus 2 pi r squared. All right, 2 pi RH plus 2 pi r squared. Two pi RH 2 pi RH plus 2 pi r squared. So we have 2 times pi. R is 2x plus 3. H is 3x squared plus 5. Okay, plus 2 pi, and then r squared. We did r squared up here earlier. Okay, so do y'all remember this right here? I'm going to highlight it in blue. Highlight it in blue. Here's r squared, which was this right here. So I'm going to go ahead and write that expanded version down here at the bottom. So it was 4x squared. So if you already did it once, no sense in doing that again. So I'm going to go r 4x squared plus 12x plus 9. Okay. All right, let me scroll down a little bit more. Okay, so that's my surface area. What do I have to do right here? I have to do the FOIL method again, okay? So I'm going to write the 2 pi out in front. I'll deal with that in a minute. So the first terms are 6x cubed. And again, if you don't understand how to do that, guys, you can do the box method over here. Okay, remember the box method. You can do 2x times, or 2x plus 3 times 3x squared plus 5. And then so this right here is 6x cubed. This is 10x. This is 6x squared. And this is 15. So in this case, we don't have any like terms. So what we're going to do here is we're going to write 6x cubed plus 6x squared plus 10x plus 15. Okay, so all of that is the first part. Plus 2 pi times all of that. All right, so 2 pi times all of that plus 2 pi times all of that. Now, here's one thing that we can do. Since both of them involve 2 pi, okay, you can distribute out the 2 pi, okay? I'm not sure if you remember that algebraically. Or you can just distribute, or I meant to say factor out. You can factor out the 2 pi and then combine these two right here. Or you can distribute the 2 pi to each one. Okay, so you can distribute 2 pi times that, times that, times that, and times the 15. And same thing over here. You can distribute all of that. So what do we do next? That's up to you. There's different choices that you can do. That's the great thing about algebra. There's different routes that you can take. Me personally, since I see 2 pi in both of those, here's what you are allowed to write. You can write 2 pi times, and then everything inside the parentheses. So we have 2 pi, we have 6x cubed, we have 6x squared and 4x squared, which ends up being 10x squared. And then we have 10x and 12x, which ends up being 22x. And then we have 15 plus 9, which ends up being 24. So hopefully you can understand what I did there. I factored out, since both of these have 2 pi, I am allowed to add those two since they both have 2 pi. It's kind of like terms also, if that's another way you want to think of it. So now I do have to distribute the 2. I'm not going to distribute the pi because I don't want to write pi over and over again, but I do have to distribute the 2. I have to do 2 times all of those terms, okay? So I'm going to have pi out in front times 12x cubed, because that's what 2 times 6x cubed is, plus 20x squared plus 44x plus 48. Okay, now what I am going to do is I'm going to move, well, I can't do that. I'm going to move the pi out on the other side because that's just how we usually say it. And this is in units squared. So my final answer is this right here. Okay, if you wanted to distribute the pi, this is how your answer would look. You would just have pi on every term. You would have 12 pi x cubed plus 20 pi x squared plus 44 pi x plus 48 pi. Do you see how that's the same thing? Most kids in the past that like to leave the pi out in front like that, but you make sure you have to include that parentheses, okay? So those are very important. So I'm going to highlight those 2 parentheses. You must include that, okay? And those are our 2 examples. I know the algebra ones seem a little bit much, so if you need me to have a Zoom conference meeting with you, I'm more than happy to do that, and I can show my screen and show you how to work some of this stuff out, okay? I will send you the answers to the homework for you to check, and you can see all my work shown there. All right, this concludes this lesson.